we've had centuries of working with materials that come from below ground and at great cost to our environment. And we're just now starting to sense the opportunity that exists above ground.
Welcome to the Business for Good podcast, where we spotlight people making money by solving some of the world's most pressing problems. I'm your host, Paul Shapiro, author of a nationally best-selling book on food sustainability and CEO of a company in the same space. On this show, I speak with founders, investors, and thought leaders who prove that doing good and doing well can go hand in hand. The biggest challenges facing humanity are solvable and are often profitable too. My hope is that this podcast informs, inspires, and maybe even helps propel you to build a business that makes the world a better place. I'm glad you're here. Welcome, friend, to episode 192 of the Business for Good podcast. A few episodes ago, in my conversation with Jim Mellon, the billionaire investor, I offhandedly mentioned to Jim that I had recently torn my meniscus in my knee and that I needed surgery. It was very touching to me that several of you reached out to offer your well wishes, so I'll give you the briefest update here. I had the surgery, which lasted about 12 minutes, I'm told, and a month later, I'm already back to running. So it comes at a good time, though, since I have an annual tradition around July 1st of each year to get my VO2 max tested. So at least I have a couple weeks to try to build back up some endurance before getting into the lab and doing it. We'll see what happens. Okay, on to more important things than my knee and my fitness level. First, here is your random wild fact of the episode, which I learned from recently reading the book, The History of Money by economist David Williams. It's a very interesting book. Basically, we use base 10 math largely because humans have 10 fingers. Ancient Mesopotamians, though, used a base 60 system because 60 is so divisible. Think about it. You can divide 60 by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. That makes fractions and measurements a lot easier and more convenient. And this is actually still why we have 60 minutes in an hour and 360 degrees in a circle. So even though we switched from base 60 to base 10 math, we still are using base 60 in some things. All right. Now, I think you're going to enjoy this episode because it's about something that very few people think about, but it's pretty interesting when you do think about it, and that is the buildings that you spend most of your life in. Now, what if the buildings that are around you, the steel, the concrete, the plastic, what if they weren't just shelter, but actually part of the climate problem? On this episode, I sit down with Allison Dring, CEO of Made of Air, to explore a pretty far-out idea. What if buildings could actually remove carbon from the atmosphere instead of emitting it? Right now, the built environment is responsible for roughly 40% of global emissions, much of it hidden deep in the materials we rarely think about. Beneath the surface of every wall and every facade lies a story of mining, fossil extraction, and energy-intensive processing. But what if we flipped that model? Made of Air is doing exactly that, transforming waste biomass into carbon-storing materials that can replace high-emission building components. Instead of digging resources out of the earth, they're working to harness what's already above ground and locking it into the very fabric of our cities. The implications are staggering. If scaled, this approach could eliminate global emissions tied to building materials and even go further, turning buildings into long-term carbon storage systems. No building on Earth today is fully carbon negative across its life cycle, and scaling the solution raises a lot of tough questions, like where's all this biomass going to come from? Can this compete on price? And is the industry actually going to change? The conversation between Allison and me doesn't shy away from those tensions. It's about more than materials, though. So rethinking the physical world itself. Because if companies like Made of Air can get this right, the cities of the future maybe just won't house us. Maybe they just might help save us. Okay, before I give you Allison, as always, here are your 3 key takeaways. First, we're building the world from wrong materials. Most of what surrounds us comes from below ground, fossil fuels and mined resources, and we could be using materials that come from above ground and actually store carbon. Number 2, second, buildings could flip from being part of the climate problem to being part of the solution. In other words, instead of emitting carbon, they could lock it in a way, turning cities themselves into carbon sinks. And third and finally, the bottleneck isn't the technology, it is adoption. We already know how to do this. The real challenge is getting industries, investors, and policymakers to move fast enough to make it happen. With that said, I now give you the CEO of Made of Air, Allison Dring. Allison, welcome to the Business for Good podcast.
Thanks, Paul. I'm really happy to be here.
Great to be talking with you. Now, you're in Germany, but your accent does not sound very German. In fact, it sounds very American. So I take it you are not a native to Deutschland.
That's right. I'm actually from San Diego.
Yes. Okay. That makes much more sense. So you made the trek from San Diego to Berlin. Why? What led you to escape the U.S. and go to our old foe, Germany?
Yeah, a very strong sense of curiosity. I went to grad school in London and just really opened up the world for me. I lived there for about 10 years. And
Wow.
During that time, just was really attracted to Berlin. It kind of had everything I wanted in London, but it was a bit cheaper and just a bit cooler. So
Now,
migrated.
When you were in grad school, were you thinking, oh, I want to be an architect? Were you thinking like, I want to get into materials? Like what were you intending to do with your life at that time?
Yeah, I mean, I was studying architecture and I was fascinated with space and cities and all this kind of, all the pieces of architecture. Being a professional architect was really not kind of where I wanted to go from an early start. So I was sort of more interested in investigating buildings than building them. But I didn't know about material science at the time. I didn't think about it that way. I really just saw it as a whole field to explore and to be critical in. And that's really how I set out with no real roadmap in mind.
And were you thinking that you had a passion for protecting the environment, or did that come later? Like, do you think I want to investigate buildings because I want to do something good for Earth? Or was it that you were interested in investigating buildings and it turned out that something actually could be good for Earth?
I was fascinated by any technology that could be self-sufficient and in that way sustainable. That was what started it for me. I think I really wanted to jump into technologies. I wasn't afraid of any kind of deep technology to explore sort of what sustainability could be. I didn't really accept the regular paradigm of sustainability in building at the time, which was let's build less. I think that was what put me off from the beginning. But I was always fascinated with how can we build better.
Okay, so before we get into how you are building better with biochar, it sounds like better living through chemistry, better building with biochar. Okay, before we get into that though, what's wrong with building? Like what when I walk into a building, you're saying it's not self-sufficient, you're saying it's not sustainable. Like what's the problem with it?
Yeah, I think if you look in the value chain of how a building is made, the really critical point is in the raw materials. And in most buildings that you're probably sitting in right now, that I'm sitting in right now, the resources that are going into that building are mostly from below ground. So we're talking about fossil materials, mined materials, concrete, thermoplastics, phenolic resins that are going in to make our buildings. And I think that's not really apparent to everybody who inhabits the building because we're really only dealing with the outer finishes or the very final finishes of the building. We're not really thinking through how it was put together. And I think that's where I had a very privileged position in architecture to understand all of the components and the resources that we're feeding them. And that's where I think the problem is. And the bigger global perspective of that is you have 40% of the world's emissions coming from the built environment. And a good chunk, nearly half of that, is in the materials that we're using to make building products, to make our buildings. So you have to look very deep in the value chains to see the problem, but the problem is enormous.
Okay, that's a shocking statistic, the 40% statistic. So what is it that is so bad? You're saying we have to mine, right? So we're taking metals or fossil fuels out of the ground and then we convert them into these buildings. Is the problem, in your view, the mining, that's despoiling the local environment? Is it the emissions that are heating up the entire planet? Like, what is the actual problem? I mean, we mine all the time for all types of things, and we need metals in our lives. So what's the problem?
There's a whole spectrum of problems in that. And I think where we focus in is on the emissions problem. It takes a lot of energy to extract resources from underground. In the case of fossil materials like plastics, you are emitting CO2 into the atmosphere as you create them. With mined materials, you're just also releasing a lot of CO2 and the energy that it takes to extract them, to grind them, to reconstitute them and make products out of them. So you have a kind of multi-fold problem from just using these materials because they come from underground. And what we consider like really fascinating about this planet that we're on right now is that we have resources above ground that we haven't even tapped. So if we think about mining, we have CO2 in our atmosphere that we could mine. So if you think about it differently, there are resources that are bio, that are above ground, that are waiting to be tapped. And they need technologies to convert them into real materials that we can use in an industrial way. So this opportunity, we're just at the beginning of this opportunity. We've had centuries of working with materials that come from below ground and at great cost to our environment. And we're just now starting to sense the opportunity that exists above ground.
Okay, so let's talk about what that opportunity is, Allison, because right now, we're basically taking all these materials from Hades, right? We're going way down to Hades. We're taking all this stuff out and bringing it back up. But you're saying there's a lot, like one example you give is CO2 in the atmosphere. I presume you're referring to direct air capture, right? Where you're trying to take CO2 out of the atmosphere and turn it into something that is useful. We have devoted past episodes of this show to that issue before. But you are not taking CO2 directly out of the atmosphere with made from air. Rather, you're doing something very different. So tell us, what is it why are people funneling millions of dollars into your company? You have this technology to make materials from things that exist above ground. What is it? And why is it attractive?
Yeah, I mean, we're focused on a technology that's called biochar. This is an IPCC approved carbon removal technology. But that sounds very complicated. It's a very simple thing.
Yeah, and just for those not initiated, IPCC is the International Panel on Climate Change. Excuse me.
Yes.
So those who aren't initiated, okay. So it's IPCC. Go on, please.
So biochar is this great carbon removal technology, and it's really just based on waste biomass. So plants are doing all the work. Through photosynthesis, they're capturing CO2 from the atmosphere. So they're doing the direct air capture. But what we have in the regular plant cycle is as a tree starts to decompose left on the ground, all the CO2 that it's stored over its lifetime naturally goes back into the atmosphere. So what we have is just a carbon neutral cycle where it's absorbing the CO2 and it's re-releasing it. And what we have in biochar is this process of baking the waste biomass into an oven, which is a very high temperature, low oxygen oven. And you get a kind of charcoal material out of the other side. But what's happening in terms of carbon is you have all the CO2 that's stored in the plant material. It gets converted into elemental carbon. So on the other side, in its charcoal form, it never re-releases the CO2 back into the air for like 1,000 years. It's a permanent form of taking all the work that the plants have done and making a permanent material. It's sequestering all that carbon, and we can get it into use and we can get it into the ground. So that's essentially what biochar is doing. It's a low tech technology. It's done all over the world. It's produced for energy or for heat or for farming. Farmers use it on their fields. And we think it has a massive opportunity as a new material category that can work in building materials.
Okay, so let me just back up and first ask, I presume, the process you're talking about, which is called pyrolysis, like this low oxygen, high temperature process, I presume the energy that is needed to create that chamber where it's very high heat, low oxygen is lower than the energy that you're storing, right? Like the emissions from that are less than the emissions that or the CO2 that you're capturing and putting into this 1,000-year long storage, right? Is that accurate?
That's right. Yeah.
Okay. So let's talk about then what these plants are, right? So to the untrained ear, you're talking about plants. It sounds like you're just going to go cut down a bunch of trees and then use pyrolysis to turn them into building materials. I can't imagine that's what you're actually doing, though. I can't imagine that you want to deforest the planet in order to build buildings. So what is it? What are the plants that you're using?
Yeah, a lot of the biochar that we're using is derived from wood waste, and that comes directly from the wood industry. So it's been proven that we have working forests that are producing wood to be able to build with. And this is what we want to do in terms of emissions. We want to replace a lot of the mined materials, the structural materials of our buildings. We want to start using more timber. The wood industry exists. It will always exist. It's good for the planet. It's good for the forests. What happens along the way with the wood industry is there's a lot of waste created. You have sawdust, you have very small chips from the wood, so very downstream waste. And that waste right now doesn't have a lot of use. And converting it into biochar captures the carbon that it has. And then there's all kinds of possibilities. You have carbon credits, you have applications in the soil. So a lot of companies are deciding to do this. The world is now making a lot of biochar. You can also derive energy from it. And this is a new waste stream that it's going to be in oversupply for a lot of the markets that it's targeting right now. But there aren't enough technologies that are able to take it as a resource and turn it into an industrial material that manufacturing can rely on. And that is really where we come in.
So what happened to these little wood chips and all that sawdust in the past? You're calling it a waste stream. Does that mean it literally goes into a landfill, or did something else happen? All right, so it's going to a landfill. Okay.
Typically it's landfill. Yeah.
So you're taking something that would have gone into a landfill and you're converting it into building materials that will replace high emissions building materials. Like what? Is it replacing steel? Is it replacing cement? Like what does your product actually replace in the building process?
Right now we're working on a cladding panel, so non-structural application. This panel is carbon negative. It has so much biochar in it that it's generating negative emissions. And it replaces panels that are most often used in buildings are steel formed panels, any kind of metal formed panel, a cement fiberboard panel, thermoplastics, phenolic resin materials like high pressure laminates. So these are all kind of board applications that are based on mined materials like cement or fossil plastics. So we can replace with the same performance in those product categories. We can replace all those high emitting materials with a carbon negative product.
How interesting. And why would the builder want to use it? Are they getting carbon credits? Is it cheaper than the material that they're replacing? What is your pitch? Obviously, they're not going to do it just because they care about climate change.
Yeah, it's hard. This value chains are so wide. There's so many stakeholders involved. The specific category of builders or contractors, they're a little resistant to change. They've seen a lot of innovation that hasn't worked in the past. So the industry is a little conservative. And what is the incentive for a contractor to do it? Well, I think real estate is starting to think differently about their assets. That's really the incentive in the value chain is at the end. So real estate is starting to see regulations coming both in the EU and the US that are targeting exactly the problem we just talked about, which is embodied carbon. It's the emissions in the materials themselves. And a lot of real estate is really thinking about long-term compliance. I'm not just going to build a building that has human inhabitation. It's what we're building is a material investment that is decades long. And we need to understand compliance in a different way. We understand what's happening with the climate beyond the current political moment. We need to think in the 30 to 50 year life cycles. And I think we're seeing that change happen both in policy levels in the EU and the US. But we're also seeing just real estate taking a different risk bet basically on the assets that they're building. And that's driving a lot of change in the value chain. I think with the other stakeholders, they're sensing opportunity. That's creating market opportunities at every point.
Okay. So, when you're talking about carbon removal companies, virtually all of them are selling credits, right? They're selling carbon credits to virtually tell people there's a market for carbon credits. We think we have this great certification program. You can do this and pay for that. And that's how the money is made. It sounds like you're not selling carbon credits. You're selling materials, right? You're actually trying to remove the CO2 from their process, not just have them pay for their sins of all this CO2 emission, right? So why is that better? Why is it better just to sell the materials rather than to sell the carbon credits?
Yeah, I mean, ideally, we'd love to do both. So I think we're tackling the problem head on. There's the problem is upfront carbon. You're building and you're making material decisions, and each one of those decisions has a whole stack of emissions associated with it that you can't reverse later on. So we really want to tackle that problem first. If you're about to specify a very high emissions product onto your building, if we can stop that and replace it with negative emissions, that's problem number one. There's a value to that. We aim to be cost efficient with our product. We're not a high end product. We're aiming to meet the market where it's at, and be able to replace products for the same price. So no green premium is kind of our first rule here. But the second, of course, like carbon credits, that's tricky because we're talking about, essentially permanence in the material, but you can't necessarily validate the permanence over the life cycle. That's really the issue that the whole industry is facing. You really need building owners to sign up and say, we're going to put this material in place and we're not going to touch it. The same way that forest owners have to think about forests now. And we need to see that chain of custody going through probably many owners to reach 100 years before you're seeing like real carbon credit opportunities.
You mentioned, Allison, that the company is aiming to become price competitive with the carbon intensive materials you seek to replace. And then you said that your first priority is to make sure there's no green premium. It sounds like you're not yet there, or maybe I'm mishearing you, but it sounds like you're not yet at price parity. How long do you think it'll be before a building construction company will want to use Made of Air's products simply because it's cheaper?
Yeah, our target for market parity is the end of 2027. We are right now.
Yeah, that's pretty close.
Yeah, it's within reach. We're working in a pilot facility right now. A lot of our costs right now are tied to just having a smaller facility. So it really isn't a big technological change that we're talking about to be able to reach market parity. It's really just a matter of scale.
If you succeed, what fundamentally changes? If I am going into buildings and it's made from your biochar, is it plastics? Is it metals? Is it construction? Like, what do you think is the most likely change in the world if Made of Air succeeds?
Essentially, I think we're taking out the very commonly seen metal panels, so aluminum and steel panels that you're seeing on just about every building. Also cement fiber boards. So seeing those change out, and it isn't really perceptible. We're not making a niche product. We want to keep the same performance that those products are able to deliver right now, and we do. I think we have certain product characteristics that are maybe they look a little more biological. The surfaces aren't always perfectly, they're not as perfect a surface as an aluminum panel, for example. But we think our customers are really appreciative of that this is a new age and that buildings are going to look different because they're performing differently. So I don't think it's going to be in your face, but I do think you'll see, we have colors, we have a black core. So there's a very identifiable aesthetic with our product, that you see a carbon core and a very nice surface that we can control different colors and different textures. So we can really be flexible in a lot of things, but we're still carbon at our core.
Yeah, I like that. Carbon at the core. Okay. Allison, if every building became a carbon sink, like what you are proposing, how much climate change would that realistically solve? You mentioned 40% of the emissions coming from the built environment. Is that your answer? Is it 40%? Like, if every single building on Earth was using your or a competitor's technology, what realistically would that actually do for the climate problem?
Yeah, I mean, that's a very interesting question. So like 40% of the global emissions the breakdown of that is about half in energy. So, operational emissions is about half of that. The other half is the embodied carbon, the material emissions. So using our materials as a formula, if we could get it into every building product in the building, which would be fantastic, we would wipe out that 20% emissions that are standing right now. But more importantly, we can offset emissions from other industries because we're creating negative emissions from the building. So the building flips from being an emitter to a carbon storage facility. And I think this is where it gets very interesting. And those emissions start to act as a drawdown. So you essentially have buildings being made from carbon that we've drawn down from the atmosphere. And that's really that's what got me into this in the beginning. I think I've always seen that opportunity for our built environment to be active in that way.
Is there one building on Earth today that is a drawdown building? Is there somewhere on Earth where you would say, hey, go here, even if it's not made with your products? Is there anywhere on Earth where there's a building that fits the description that you are enumerating?
There is not a building that I know of today, right now, that has a whole life cycle emissions calculation that is negative.
Okay, wow.
But I am a big believer in it. And I think we have all the technologies to be able to do it. It's really just a matter of signing it up and getting it going.
Yeah. Okay. So, there's millions and millions and millions of buildings on Earth. You say you already have the technology to do it, but do you have the feedstock to do it? You mentioned there's a lot of sawdust on the planet. What I'm wondering is what happens if you succeed? Are you going to have enough so-called waste products from forestry to make this happen? Or are you going to need just whole trees, right? Already we have like biomass energy generation where they literally are deforesting entire forests just to burn up trees in a so-called, green energy, which is not green at all, but it is, allegedly renewable because trees regrow, but it takes decades. But I doubt that that's what you envision for Maida Vare's success, to cut down whole forests so that you can build buildings. So where is the feedstock going to come from if you're going to be making enough to be a multi-billion-dollar industry here?
Yeah, I totally agree. And we're not talking about cutting down trees. We're talking about working agriculture. 70% of the world's usable land has been worked on by humans or has been controlled by humans. So we're already talking about land maximization. We don't want to see forests being cut down for something like this. What we want to see is a smarter management of resource. There is enough biomass waste in the world to be able to do this, to turn every building into a carbon sink. What we're looking at first is biochar derived from wood waste. You do that because it's a standard in the industry. It's where biochar started, but it's not the only biomass stream that you can get biochar from. The world's agriculture produces very, a disproportional amount of fruit or harvest than stover, which is the leftover agricultural waste. Massive amounts, usually burned on fields. So the CO2, again, going back into the atmosphere. You can make biochar from like rice hulls. You can do it with sugar cane, coconut shells, bamboo. Like, you can imagine how massive these industries are. And how cyclical they are.
Is there a technological reason to start with wood as opposed to coconut shells or banana peels or corn husks? Like, what is it that there's just more energy in the wood than there is in these like cellulosic other ingredients?
Yes, that's true. There's more carbon content. They're more ligneous, the wood waste. So that is really where we started. It's also that the industry started there because the wood industry is so advanced that we already have kind of smarter ways of dealing with waste. It's also that we're based in Europe and also working a bit with the US, and in those regions, we have very active working forests where the wood industry is very smart about its resources. So that's where we started, but there's every reason to believe that this technology works as you change the biomass inputs. Yeah.
Interesting. Okay. So there's every reason to believe it, but we will see. I hope you get a chance to prove that those reasons are believable. You've been at this for 10 years, Allison.
Yes.
One of the rules that I have noticed about climate tech is that things generally take a lot longer than anticipated and they take more money than anticipated. 10 years ago, when you were starting the company, did you think that you would be where you're at now? Are you further ahead or further behind or right where you thought you'd be a decade later?
Yeah. I mean, you always want things to move faster. I think if you're an idealist, you imagine the place you want to be very quickly and you don't see the challenges right away. So that's where experience comes in and the growth that has happened over the 10 years, both myself, both within our company and also within the communities, the environment that we operate in has changed quite a lot too. So when I started having these conversations about biochar, it took about 5 years before I could say we're working with biochar and not have to explain what that was, even to climate investors. So I think the context around us changed a lot. But definitely there have been challenges. Things take longer. Deep tech, it's called deep tech for a reason. It takes a long time to come out of the lab and into commercial projects. But I'm happy to say that we've done that. We've also built quite a moat. So the great thing about the time spent at Maida Vare is that we've built incredible foundational IP around solving the problems associated with biochar coming into a material composite. And that for us, that is really the link between the production of biochar on one side and the demand for better low carbon materials in the built environment on the other. So I think that time was well spent. But obviously, yeah, getting the stakeholders to align, getting the industry to think differently, getting policy to be very specific about these problems. I never anticipated that the organizational issues would be the bigger challenge than the tech. Yeah.
Interesting. You mentioned that you were trying to explain what biochar is to climate investors. There were a lot more climate investors 5 to 10 years ago than there are now. So how much money have you raised so far? And how much money do you think that you need in order to get to full scale and profitability?
Yeah, we've raised just over 12 million euros. We have incredible early investors that have stayed with us from the very beginning. And so we're quite proud of what we've built together there. We're just about to raise a Series A. We're targeting the end of the year close on that. And the number is still out on how much we'll raise there. But our target is to grow the company and to expand the production capacity that we've built here in Berlin. We're adding equipment to our pressing capacities. And
nice.
Yeah, I don't have a number necessarily right now, but watch this space.
Presumably, considering this environment, anything you can get. But it is quite a statement that a 10-year-old startup that has already raised $12 million would say, we're now going to go raise our Series A, right? Yes. This is unheard of, 10 to 20 years ago to have 10 years before a Series A, whereas so many companies are now in that space where you're raising millions of dollars in a pre-A round and spend years and years inventing tech before you ever do a Series A. That is definitely a sign of the times for sure.
Exactly. Yeah. And I do find it to be the new normal. I think a lot of investors, or at least the context around investing has been default in software for so long. So the metrics that you're hearing about, how fast do you raise a Series A, these really come from software investments. But when you go into hard tech, and especially into climate hard tech, where you're building first of a kinds, where you're prototyping technologies that have never come out of the lab before, I think this, in the kind of urgency that we need them to happen, this phase is a whole new normal. And I'm really seeing a lot of companies just like ours. I hear a lot more common stories with ours than the ones maybe that you hear about in software. So it does seem to be ringing true. It takes time to build new material categories.
Well, it certainly begs the question of how patient the investor capital is, right? Like if you're looking if you're a VC and you've got a fund that's maybe got an 8-year lifespan and you're saying that you're not even going to do a Series A for 10 years, these climate tech investors have to start thinking, how long do I want to wait until I get a return for my LPs? And this has, been, I think, one reason among others that you have so many fewer climate tech investors these days than there was 5 or 10 years ago, for sure. I see you nodding in agreement. So yes. Let me ask you, Allison, you've been at this for a decade now, as I mentioned. Are there resources that have been helpful for you in navigating startup land, raising 12 million euros, which is, most startups never raise 12 million euros. Most startups don't last even 5 years, let alone 10. So by many metrics, you've already succeeded well beyond the success of most startups, including in climate tech. What's been useful for you? What would you recommend for somebody who's thinking, I want to start my own climate tech startup? Is there something that you would recommend to them that they check out?
Yes, I think, we have been so privileged over the years to be associated with different groups that have made all the difference for us. I think if you're starting a new company, context really, really matters. You have to know the right people. You have to get in with a community. You have to know other founders and really hear their war stories. Don't listen to their press. Don't read LinkedIn. Really talk to them over a drink. They get their truth. And I think that made all the difference. And one of the places that first opened up for us was what used to be called Elemental Accelerator is now called Elemental Impact. They were instrumental in working with us. They do a kind of it's not really an accelerator, but they do a program where they're educating companies in a portfolio context with other companies and really talking them through what is market entry, what does it take to bring your technology forward, what is the climate problem you're solving, and what is the commercial problem you're solving, and are they the same thing? And so it was, I think, just having a lot of those toolkits in our hands early on made all the difference. Carbon to Value initiative out of New York was excellent. It grouped us in with companies that were thinking about not just how do we get carbon out of the atmosphere, but how do we put it to use, which is sometimes the bigger challenge. They're fantastic. So we worked early on in their first cohort with them. And also the Respond Accelerator here in Germany, run by the BMW Foundation and the Technical University of Munich. And that helped us ground in with how to be a company in this space, how to do it differently. A lot of the company structures in the past aren't aligned. They're not aligned with climate, with how you think about climate, even your own company structure. So there was a lot of learning that we had in those. I'd say those three channels really made a huge difference for us.
Okay, well, that's helpful. We're going to link to all three of those in the show notes for this episode at businessforgoodpodcast.com. I'll also just augment what you said by stating it is unbelievable to me, the gap between what startups say, like how they say their company is going, and often how it is actually going, whether it's on LinkedIn or elsewhere. And whenever I read like a really glowing profile of a startup, I always think it can't be going that well. And conversely, whenever I read like an expose or some story, I always think it can't be going that bad. I always think it's like way more exaggerated, both positive and negative, because my experience in talking to many founders and in being a founder myself is that there's oftentimes great things and horrible things happening simultaneously, just all the time, right? Like there's just good and bad things. And frankly, even for successful companies, usually more bad than good, or more challenges than good. And so whenever I talk to somebody, I'm like, oh, how's the company going? And they're like, oh, dude, we're killing it. I'm like, just tell me the truth. Like, tell me, I'm sure there's many good things that you're proud of, but come on, like seriously, there's many challenges too. So it's funny you say that, and especially on LinkedIn. I would like for somebody on LinkedIn just to post all the things that are going wrong with their company.
Absolutely.
That would be a really interesting post to read for sure. Yeah, I would really welcome that. And why it's their fault rather than somebody else's too. Like that would be like a really good one. Yeah.
Radical honesty.
It's right. It's not their investors' fault. It's not their employees' fault. It's their fault. It's the founder's fault. That would be a good one. Okay. You're talking about resources for many of which are these accelerator programs. Are there companies you think somebody else should start, Allison? You're obviously committed to doing Made of Air, but surely there are other companies you think that could be helpful, whether with climate or some other important issue. So if somebody's listening and thinking, this is really cool, maybe I should start my own company, what do you think they should do?
Yeah, I think, the question that I had in the beginning, which was how do we shift our idea of resources from below ground to above ground? There's a lack of technologies that can take those raw resources and really turn them into industrial materials. I am committed to materials, as you can tell. So when I think about that space, I think that there's not enough companies there. I think it's an expanding space. I don't think it's, what do you call it? Red ocean. I think this is an expanding, it's an expanding market. We're seeing a lot of drive in the built environment, but we're also seeing in other segments. We work with automotive companies, we work in logistics, and that material problem is happening deep in a lot of supply chains that you're not going to hear about. And the more that we can transform those bioresources into biomaterials that are able to move into those supply chains quicker, I think that's really where the inflection point is. Like I hear it from both ends. I hear it in the agricultural and the biomass sector. I hear it in industrial manufacturing, and I think joining that up is the inflection point our global emissions story needs. So if you're working in that space, if you're working in material science or anything in bio, I think that transformational activity right there between resource and industry is we need more people like you if you're thinking about that. Okay, very cool. And I will note, Allison, when you said that you are committed to materials, as somebody who is a Madonna fan myself, I thought, well, maybe you should call yourself the materials girl, right? Like, like this, like, if Madonna is the material girl, Allison Dring could be the materials girl. So I don't know. What do you think about this moniker? Favorable or no? I'm not such a Madonna fan, but but I get you.
Okay.
And I like the reframing. I think that's really interesting.
Okay, very good. Well, I hope you change your mind about Madonna, but in the meantime, I'll be rooting for your success, Allison. It's very cool what you are doing, and I hope you are able to successfully raise your Series A and scale the company and create a lot of carbon negative buildings. And the next time somebody asks you, where's the best building to exemplify this type of change, it will exist, and we can walk into it together and feel the carbon being sucked out of the atmosphere right there. So that would be a lot of fun.
Thanks for listening to the Business for Good podcast. To explore more conversations like this one, visit businessforgoodpodcast.com and be sure to subscribe so you don't miss future episodes with founders, investors, thought leaders, and more, turning global problems into powerful opportunities. And if this episode resonated with you, please share it with your network. You never know who you might inspire to be in the business of doing good.